Hey guys, this video is about CPCTC, which is directly related to all of the triangle congruency shortcuts. So in order to be successful in this unit, you want to go back and make sure that you understand how to use each and every one of those shortcuts from our last chapter. So CPCTC is an abbreviation that stands for corresponding parts of congruent triangles are congruent. And so essentially, if you know or you can prove that two triangles are congruent by using one of the shortcuts, in this case we have AAS, then we know each individual set of corresponding parts that even if they don't have a mark on them, they must be congruent because the triangles themselves are congruent. So for example, we have angle A and angle D must be congruent even though they don't have an arc. BC and EF must be congruent, and AC and DF must be congruent, even though they don't have tick marks on them. So feel free to write these notes on this worksheet, which goes along with this video. That way you don't have to recopy all the diagrams into your notebook. So hopefully you were able to get down what the abbreviation means, and I would have also drawn an example, either take the one that I gave you, or you can make up your own, or you can use this one right here. So if you know, let's say, you know these two triangles are congruent by SAS, you also know that all of the parts are congruent. So a good way to think of this is like, if the triangles are congruent, then the parts of the triangle are congruent. And that just makes sense. Every time you use CPCTC in a proof, you're going to follow these two main steps. So the first step is just exactly what we've been doing on all of our triangle proofs so far, and that is to show that a pair of triangles is congruent by using one of these shortcuts. Or you could use HL, which we'll talk about in the next part of this unit. Okay? So after you have proven that the triangles are congruent, then you can tell me that the parts are congruent. So a set of corresponding angles or corresponding sides would be congruent if the triangles are congruent. So let's go ahead and try this first proof right here. So we always start off with the given just like normal, and it just so happens that the given information in this particular proof is enough to tell me that these triangles are congruent because I have a set of sides that are congruent, set of angles, and then another set of sides. So this would be SAS. And so the difficulty about these proofs is that now there's no statement to copy over. It's up to you to match up the corresponding parts correctly. So I'm going to start with N. Triangle NMP is congruent to triangle N matches up with R, M matches up with Q, and P matches up with S. Now remember that you don't need to have the exact same answer that I have right there. You could have started with P. PMN is congruent to SQR, as long as each of the parts is in the correct position to match up with the part that it's congruent with. Okay, so I want to now be able to show that NP is congruent to RS. And back to what we were talking about before, if the triangles are congruent, then the parts must be congruent. So I can now say NP is congruent to RS because of our new reason, CPCTC. Alright, let's go ahead and try example number 2. If you haven't already, jot down your given, and then we want to start marking up our picture like we always would. So the first thing they tell us is that M is the midpoint of AD and BC. So I would encourage you to pause the video, start marking up your pictures, and see if you can start proving that these two triangles are congruent. So I would put tick mark on AM and MD, as well as BM and CM, because I know that M is the midpoint of both of those segments. Then I would need to write that down. So AM is congruent to DM, CM is congruent to BM. And the reason for that is I see the word midpoint, so definition of midpoint. I also see a set of vertical angles. So here's my vertical angles. I'm going to name those angles angle AMB. Remember, the vertex is always the middle letter. So that must be congruent to angle DMC. And that's because vertical angles are congruent. And so now I've been able to gather enough information to get to my shortcut SAS, and therefore my triangles must be congruent. So triangle ABM congruent to triangle DCM. So again, those same two steps. Whenever you're trying to prove that a set of angles or sides is congruent, step 1, prove the triangles are congruent. If the triangles are congruent, then the parts are congruent. Because of CPCTC. Alright, example 3 should look pretty familiar. We've done a lot of proofs like this one so far. So again, I would encourage you to pause the video at this point, see how far you can get in this proof. If we're trying to prove that these set of angles are congruent, that means I need to do the two steps. So first, prove the triangles are congruent, and then second, prove the angles are congruent. Okay, so if triangles are congruent, parts are congruent. Okay, so hopefully you're able to get to somewhere around this point in the proof. Just to be clear, that these 3 steps can be in any order. None of those steps are dependent on one another. They're all independent of each other, so it doesn't matter if you put my step 4, if you put that first or third, it doesn't really matter. But what does matter is that you do have all 3 of these steps. So you should have noticed a reflexive side, that there was a midpoint, and that there were perpendicular lines which form congruent right angles. So because of those steps, I can prove that my triangles are congruent. And again, you want to make sure that you match up the corresponding parts, but you don't necessarily have to start with angle A. You could start with D or B. I know that those triangles are congruent by my shortcut SAS. And if the triangles are congruent, then any corresponding parts of those triangles must be congruent. Alright, parallel lines in a proof. So we've had some questions throughout the last week about what do I do when there's parallel lines? So you do the same thing you would always do when you have parallel lines. You look for pairs of congruent angles. So alternate interior, consecutive interior, corresponding, alternate exterior, all of those should come into your mind. They do give you some information that you could use right off the bat. So MQ is this, is congruent to NR. That's going to be helpful. They give us a set of congruent angles, which they have marked, and then the parallel lines, MP and VR. Some people like to expand these. I think that's helpful, or use colors, and then notice that this is the transversal that cuts through both of them. So I can see right here, we have alternate interior angles. So pause the video again, see how far you can get. You want to, again, start trying to prove that these triangles are congruent before you can prove that the parts are congruent. So at this point, we have 2 sets of congruent angles, which tells me that I could either use AAS or ASA. So then I want to go to my diagram and see if I can try and figure out at least one of the sides in my picture. So the only thing that we know is these segments, but MQ is not actually a segment of a triangle, but MN is. And so what I noticed about that given is that both of those segments share NQ. NQ is being overlapped. And so if I take NQ away from both of the given segments, it will leave me with the segments that I want. I want MN and QR. I want to be able to show that those are congruent segments. So what I'm going to do is I'm going to set up an equation. So MN plus QN equals RQ plus QN. Right? And so the reason why I am allowed to do that is, so two things. One, I could use substitution because this is technically the same thing as MQ, or you could write segment addition postulate. So I'm going to be kind of lenient with that. You guys can pick. So you could either say substitution or segment addition. And I realize that we haven't really talked about this since chapter 1, but you guys know that when you add two segments together, it's just the total. So MN plus QN would be equivalent to MQ. Okay? Now I notice that QN is on both sides of my equation, so if I were to subtract QN away from both sides, they would cancel out. And so my next statement is going to say MN is equal or congruent to, RQ. And I know it's been a really long time. We did these algebraic proofs at the way beginning of proofs. Anytime you subtract the same value from both sides of an equation, that is ESPO, right? That's on our list of reasons. And so now I've proven that these segments are congruent, so I have ASA. And that's how I'm going to prove that my triangles are congruent. MNP is congruent to triangle RQB. Okay? And then from here it's easy. So after you prove that the triangles are congruent, all you have left is to copy over your proven statement, which should be a set of angles or a set of sides. And I know those are congruent because CPCTC again. Okay, last one, again, has congruent angles. I'm going to leave this one up to you guys and see how far you can get on your own. And then when you come back to class, we can check the answer and see how well you did. If you've got any questions on this video, please be sure to ask in class, or send me an email, or submit through the classroom a private comment if you need to.